Notation. Nick, you want to say hi to your sister before we start?
Hi, Jen.
Hi, Jenna, he says. Write down this example for me, please. 1.2 times 10 to the fifth power times 3.0 times 10 to the fifth. 3.0 times 10 to the fifth. If you are multiplying those two numbers together, one way to do it would be to change them back into standard form, which means you'd have what? A 1, 2 with 4 zeros after it. That's what this stands for. 120,000. And to that you'd be multiplying by a 3 with the same number of zeros behind it. Now I don't know about you, but when I start getting to that many zeros there, it gets a little hard to keep track of what you're doing and where the zeros are going and all that sort of stuff. Everybody like that with me? Yeah, okay. So you don't need to do it this way. There's a much simpler way to do this. And it just simply follows these rules. The first thing you do when you're multiplying two numbers in scientific notation is to multiply the left side together. In other words, take 1.2 times 3.0. Maybe you can do that in your head. Anybody tell me what 1.0 times 3 is? Jack, what do you say?
1.0 times 3.
Or 1.2 times 3?
1.2 times 3 is 3.6.
Very good, 3.6. You don't need this 0 there, it's just 3 times 1.2. Okay, that's step number 1. Step number 2 is, guess what? Multiply the right sides together. Which means I need to take 10 to the 5th times 10 to the 5th. Now the nice thing is when you multiply same bases that have exponents together, what do you just need to do, Lauren?
And
You just need to add the exponents together. And in this case, it is 10 to the 5th times 10 to the 5th is 10 to the 10th power. Okay? And then the third step you always have to look at is when you're dealing with scientific notation, you need to make sure your answer is in scientific notation. Okay, in this case it is 3.6 times 10 to the 10th is in scientific notation, so that's my answer. That's what I would have got had I multiplied all this out. I would have got this, which is 3, 6 with 9 more zeros after it. If you're writing it out in standard form, it would look like this. 3, and then this takes up one of those exponent parts, and then you have 9 more zeros to go. This would be the standard form of writing that, which nobody likes. We just leave it in scientific notation. 36 billion, sure. Now, we're going to do a problem where this last part comes into play. How about this one? 4.0 times 10 to the 4th times 5.0 times 10 to the, let's see what the book has, 5th power. 4.0 times 10 to the 4th times 5.0 times 10 to the 5th. Following the same rules, if you multiply the two left things together, you get 4 times 5 is 20. Okay, times 10. If I multiply 10 to the 4th times 10 to the 5th, I get 10 to the, Nicholas, 9th power. So it's 20 times 10 to the ninth. Now here's the problem. Step number 3 says make sure your answer's in scientific notation. This is not in scientific notation. Why? Because in scientific notation, Lauren, you don't have to have a decimal. Not necessarily. I could have left the decimal out of this and said 4 times 10 times 5 to the whatever there. I have to have the number half. Nope. Doesn't have to be in parentheses either. Emma Haynes?
It's in point 0.
Nope. If you look back in writing in scientific notation, okay, the rule is this number has to be between 1 and 10. You can't have a 20 there. Okay, in which case we just need to do a little bit of adjustment. Okay, you need to take your decimal, move it so that it is between 1 and 10, change that 20 into a 2.0, but when you do that, when you move that decimal, that changes your exponent over here. Okay, and here's what I like to think about with this, and write this down so you have some notes on it. If you make the number smaller, the exponent gets bigger. It kind of balances itself out, and vice versa. I don't know who came up with that whole vice versa saying, but it works nicely. In other words, this, boys and girls, if I move the decimal one place and make this one thing smaller, which I've done, I need to make my exponent one thing bigger. So this 9 becomes 1 bigger, and it becomes 10 to the 10th power. Had I gone the other way, if I needed to move my decimal and make my number bigger, then my exponent would do the opposite and get smaller that much. We'll do another example that will show that, Lauren.
Wait, so, but how could you get to do negative numbers? Because I don't understand how you could get in between 1 and 10. To do it like
In other words, this. If you came up with this, 0.005 times 10 to the, let's just say, negative 8th power. Okay, this is not in scientific notation because this is not a number between 1 and 10. So I need to move the decimal so that it is between 1 and 10, which means I'm going to move it 1, 2, 3 places and make that 5. You could make it 5.0 if that makes you feel better. I made this number, I moved the decimal 3 places, and I made it 3 bigger, so I'm going to make this 3 smaller, which means I'm going to subtract 3. And when you subtract 3 from a negative 8, you get a negative 11. Correct. You're adding and subtracting, not multiplying. You don't get a positive. Okay, I made this 3 bigger. It balances out by making that 3 smaller over there. Jackson?
So for how many decimal places you move it is how many you add or subtract?
Yes. However many places you move the decimal is however many number you add or subtract right there. That's a good call right there. Now, moving on to division. Division is going to be very, 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 very much the same thing. If you have 4.8 times 10 to the 6th power over 4.0 times 10 to the 3rd power. It's pretty much the same exact rules. Step number 1 is instead of multiplying now, it's dividing. So you divide the left numbers. Anybody know how many times 4 goes into 4.8? Nikki Cow. 4 goes into 4.8. 1.2. Now here's what you might want to take note of. Step number 2, when you divide the rights, what happens when I divide numbers that have exponents that are the same? Remember when you multiplied, you added them, John, so when you divide, it's subtract. So now I need to take this and subtract 3 from 6. So it is 2 times 10 to the third power. When you divide by things, you subtract their exponents. You have to be careful, because if this was a negative 3 I was dividing by, when you subtract a negative 3, that's actually adding 3. Had this been a negative number, I'd actually add it to 6, because subtracting a negative, two negatives next to each other make it positive. And then step 3 is make sure it's in scientific notation, and in this case, it is. The numbers between 1 and 10. There. I can tell you're saying, okay, hit us with your hardest problem. 1.0 times 10 to the 8th power over 4.0 times 10 to the, I don't know, 5th power, let's just say. Following the rules here. Jeremy Schwartz, what do I get if I divide 1 by 4? If you don't know, I guess you'll have to actually do it out. But you should be able to tell me it's the fraction 1/4. What is that as a decimal? But let's do it. 1 divided by 4, put your decimal in there, doesn't matter. You get 0.2 is 8, 4 goes to 25 times. Yes, I get 0.25 for the left side. For the right side, what do you get when you have 10 to the 8th divided by 10 to the 5th? Corinne Shellhammer? 10 to the 3rd, because you subtract the bottom from the top. Now here's where we have issues. That is not the right answer. It's not in the right form because it's not in scientific notation. Jackson says he thinks he can fix this problem, Jackson. So what do I do, Jackson?
You would move the decimal.
So I end up with 2.5, but I don't just stop there. What's going to happen?
You have to add 1 to the exponent.
I made this number bigger, so the exponent actually gets smaller. Remember, it's opposites. Times 10. I moved it one place, I subtract 1 from it, it's 10 squared. Less